Hi, welcome to yet another video. And in this video, I want us to discuss what we call interpolation. And we are going to discuss two interpolation formula. We are going to discuss what we call Newton-Gregory, forward difference interpolation. Let me skip some space for my explanation. We're also going to discuss Newton-Gregory, backward difference interpolation. But actually, what is interpolation? You see, interpolation is a process of finding a certain value of entry for a given argument. You see, we call this the entry, and the value of x, we call them argument. I think this is A, we call them argument. I really don't want to insist. Whenever you are watching my videos, use what we call playlists. Playlist is how videos are organized from lesson 1, lesson 2, lesson 3 up to the final lesson. How can you get my playlists? Go where you can see my photo. When you are playing one of my videos, go where you can see a circle with my photo. Click on that photo or logo. Somewhere here you see playlists. You see a number of things and then you see playlists. Move down, check various playlists. I've organized my videos into Fourier series playlist, Matrices playlist, Laplace transform playlist. There will be a whole playlist for numerical methods or numerical analysis. Also, always remember, whenever you're watching the videos, watch them online. That's very, very important so that you can help the channel grow and create more content for you. So ensure you use YouTube playlist so that you watch the videos sequentially, not watching video 3 before you watch video 2 and so on. Now, we're talking about the argument and entry. Let's say we are given the value of the argument here 1.5, not 1.5 million, negative 0.5, and we are supposed to get the unknown value of y, or the unknown value of the entry. That's what we call interpolation. Or probably we are given, or probably we are told to get, for value of x is 3.5, we are told to get the value of the unknown entry. Or we are told to get the value of y. That's what we mean when we talk of interpolation. Interpolation is the process of finding a certain value of an entry for a given argument. So at least now we understand what is interpolation. If the value of the entry you are supposed to find occurs somewhere at the beginning of the table, ideally the best formula to use is the Newton-Gregory forward difference interpolation formula. If whatever you are supposed to find, the value of the entry you are supposed to find occurs somewhere at the beginning of the table. If it occurs somewhere at the end of the table, ideally we use Newton-Gregory backward interpolation formula. But still sometimes the question will tell you, they may tell you, using Newton-Gregory forward interpolation formula, do this. If they insist it is forward, you should use the formula for forward difference interpolation. Even if whatever you are being asked to get is at the end, go ahead and use forward difference interpolation. If they leave you, they don't tell you which method to use, whether it's forward or backward, you can choose at the beginning, use forward, to at the end, use backward. Or sometimes they may tell you use backward. In that case, you must know how to use the backward difference interpolation formula. Sometimes they'll tell you use forward. In that case, you must know how to use the forward difference interpolation formula. Now, the backward difference interpolation formula states that value of the entry you want to find, we call it YP. That value of the entry you want to find, which we call YP, for example, in this case, our YP will be here. Whatever you want to find is Y0 plus P, first backward difference of Y0 over 1 factorial, plus P minus 1, second forward difference of Y0 over 2 factorial, plus P minus 1, P minus 2, that backward difference of Y0 all over 3 factorial, plus, the formula is continuous, plus, because something continuous, P minus 1 all the way to P minus N minus 1 and difference of Y0 all over N factorial. That's the formula for Newton-Gregory forward difference interpolation, where P is equal to X minus X0 all over H. What is P? What is X? X is the value of argument whose entry you are supposed to find. For example, if the question is you are supposed to find the value of Y for X is negative 0.5, then negative 0.5 is your X. X0 is the very first value on the table, or the value just above your X. You may decide to use the very first value in the table, which will be X0, or the value just above your X. It depends. To give you the same answer, people have different way of perceiving this, but they all give you the same answer. But you have to be very careful, because whichever your X0 you take, you determine how you find your P. H is the interval. For example, in this particular table, H is 1. From negative 1 to 0, H is 1. From 0 to 1, H is 1. From 1 to 2, H is 1, and so on. So at least you need to understand this. Now, for Newton-Gregory backward interpolation, which we have said, mostly you use it when you are finding argument at the entries at the end of the table. For middle of the table, there's also another interpolation formula called central difference. But we say this one because it's not common exam, we need to discuss it. But for values at the center, you can use either of them, backward or forward, whichever. But you have to be careful how you find your P. P is really what makes people to miss marks here. Now, for backward interpolation, say there's something value of argument whose entry you are supposed to get, maybe 3.5. Now this is to be an X. Whatever value of entry you are supposed to get here will be YP. YP will be equal to, for backward difference, we use Yn plus, not Y0 but Yn, plus P, first backward difference of Yn of 1 factorial, plus P plus 1, second backward difference of Yn over 2 factorial, plus P plus 1, P plus 2, that backward difference of Yn over 3 factorial. And just like the other formula, we can continue like that. Plus, it's continuous. We continue adding all the terms in between, plus P plus 1 all the way to P plus N minus 1 and backward difference of Yn all over N factorial. So the formula is continuous like that. But now, here your P will be equal to x minus xn over h, where xn is the very last value of x here. This is your xn in this case. So these are the two formulas that you are going to use in the next section. I want now to clean my table so that we can answer this question. Now this question is June, July 2019, Diploma Electrical Engineering, and we have been told table 1 represent polynomial function f of x. I didn't clear everything. We have the argument, the entry, and we are told use the Newton-Gregory interpolation formula to determine 1 f of 0.2, 2 f of 4.6. So it is here, somewhere at the beginning, here, and also toward the end. So I'm going to use here what Newton-Gregory forward interpolation formula, I think here, and here I'm going to use Newton-Gregory backward difference interpolation formula. So this one I'll use forward difference interpolation. This one I'm going to use backward difference interpolation. But if you use forward for both of them, you still get the same answer. But you have to be very keen on how you're working on it, especially how you get your P. And how you also take your values. The question is 11 marks, so the first thing I'm going to do is create a finite difference table. In the previous video, we created a finite difference table, and that's why I was insisting that it's very important you use playlists and watch the videos systematically from the first video to the last video. Also, always remember to subscribe to the channel, leave a comment, share the videos to your friends who are doing the same course. Since the table you use it for both forward and backward, I will not indicate whether it is for forward or backward here. I'll just go ahead and create the table negative 1, 0, 1, 2, 3, 4. It's going as far as 4. This is negative 1. For this question, you should be very careful. This is a mistake, this is negative 3. If you make a simple mistake, everything changes. You lose a lot of marks. Be very, very careful with the sign here. And be very careful with small mistakes. They will really cost you marks. If we take this difference, negative 3 minus 1, this is minus 2. This is negative 1 minus 3, this is positive 2. Positive 2 minus 2 is 4. 17 minus 1 is 18. 18 minus 2 is 16. 16 minus 4 is 12. It's 7 minus 17 is 70. 70 minus 18, this is 52. 52 minus 16 is 36. 96 minus 12 is 24. This one I had worked something out and it needed to ease my work. 269 minus 87 is 182. 182 minus 70 is 112. 112 minus 52 is 60. 60 minus 36 is 24. By the way, which difference is this? Let me just use table for forward difference. This first forward difference, second forward difference, third forward difference, fourth forward difference. But the same table, despite the fact that I'm using the tables for forward difference here, we also use it for backward difference. This is the fourth difference. By the way, this polynomial goes as far as degree 4 because it is ending at here. The fifth difference here is 0 because the table is ending at the fourth difference. The function is of degree 4. Say something like x power 4 minus 3x cubed minus 2x squared. It doesn't have to have all the terms, minus 2 or minus maybe 5. If the difference is going as far as 4 difference, then the degree of the polynomial will be as far as degree 4. Now, using the table, when you're answering question for forward difference, go this way, take that direction. When you're answering question for backward difference, using backward difference interpolation formula, take these values here. So let us answer the first question here. Question number 1. We need to get P. P is, let me just do like that. P is equal to x minus x naught over h. 0.2 is here. 0.2. We need this value of y here. It's what we want. So you have two options. You can take these values here, down here. See, if you take this, if you use these values down here, take 0 as your x naught. Alternatively, if you use these values here, take -1 as your x naught. But personally, I prefer using the very first value here, so that way I do not confuse when I'm taking values inside here. I might confuse. I personally prefer taking this value up here. You have a choice, you can choose whatever you think it will be convenient for you. So what is our x? Our x is that values whose p we are getting, which is 0.2. So these are x. I'll take this one as my x naught, minus, according to the formula, minus 1, all over 1, h is 1, so this will be 0 minus 1, which is 1.2, p is 1.2. So that our yp, of course, which is the same as f of 0.2, or we can call it this y 0.2. Yeah, is equal to, according to the formula, p, I think I've already mapped it. Y naught, what is our y naught in this case? -1 plus, according to the formula. So our yp now is the same as f of 0.2. Let us take the formula. I removed it. Y naught plus p, first forward difference of y naught of 1 factorial plus p minus 1 over second forward difference of y naught times second forward difference of y naught over 2 factorial plus p minus 1, p minus 2, that forward difference of y naught over 3 factorial plus p minus 1, p minus 2, p minus 3, fourth forward difference of y naught all over 4 factorial. I think I've exhausted my space. So now we bring this up here. Our yp now, or which is f of 0.2, will be equal to is now equal to y naught is -1 plus p times first forward difference of y naught. So p is 1.2. 1.2 times first forward difference is -2 1 factorial plus p, which is 1.2 times p minus 1, that is 0.2 times second forward difference of y naught, which is 4 over 2 factorial plus p, which is 1.2 times p minus 1, which is 0.2 times p minus 2, which I think is negative 0.8 times that forward difference of y naught, which is 12 over there, divided by 3 factorial plus p 1.2 times 0.2 times negative 0.8 times negative 1.8 times for difference of y naught is 24 over 4 factorial, which I think is also 24. Now I'll need my calculator. So this is f 0.2 is equal to negative 1 minus is negative 2.4 plus, this one will be a plus 1.2 times 0.2 times 4, which is 0.96 divided by 2. 2 factorial is 2, 0.48, and then this one is 1.2 times 0.2 times negative 0.8 times over there it's 12. 3 factorial is 6 divided by 6 is negative 0.384. Then the next one is 1.2 times 0.2 times 0. Is negative 0.8 times negative 1.8 times 24 divided by 4 factorial is 24 is positive 0.3456. Now let us combine. So finally f 0.2 is equal to this value minus 0.384 is one. I'm making use of one circle in my calculator plus 0.48 minus 2.4 minus 1. This is negative 2.9584. So I've removed the question so that I can get some space for working. Let's start with the first question, which is we should get f of 0.2. 0.2 is somewhere here. So we are going to take this as our x naught. This is our x. Then we use these values here. So in this case, our p will be equal to x minus x naught all over h. Our x is the values of argument whose entry we are supposed to get is 0.2. X naught is this value just above our x, which is minus 0 all over h, and our p will be 0.2. So our yp, which is f of 0.2, now f of 0.2 is equal to first one difference of y naught, which is negative 3 plus p, which is 0.2 times first one difference, we are using this line here, times 2 or 1 factorial, which is 1, plus p, which is 0.2 minus 1 times negative 0.2, then p minus 1, which is 0.2 minus 1, which is negative 0.8, times second forward difference over there is times 16, or over 2 factorial. What is 2 factorial? 2 factorial is 2, plus p, which is 0.8 times p minus 1 negative 0.8 times p minus 2 negative 1.8 times that 4 difference, which is 36, all over 3 factorial, which is 6. Then we have p, which is 0.2 times p minus 1, negative 0.8 times p minus 2, negative 1.8 times p minus 3, negative 2.8 times 4 difference is 24 all over 4 factorial, which is 24. This is negative 3 plus 0.4. Here you have 0.2 times negative 0.8 times 16 divided by 2, negative 1.28. Then next one is 0.2 times negative 0.8 times negative 1.8 times 36 divided by 6. This is 1.728. And the next one is 0.2 times negative 0.8 times negative 1.8 times negative 2.8 times 24 divided by 24, which is negative 0.8064. Let us combine them. Plus 1.728 minus 1.28 plus 0.4 minus 3 equal to, again we are getting the same answer, which is negative 2.954. So you can see, irrespective of which working you use, whether you use this one or use this one, you always get the same answer. The second question is that I think you are supposed to get f of 4.6. In this case, you need to get our p. P is x minus xn over h. What is our 4.6? 4.6 is here. So you are supposed to get this unknown value of the entry. P is equal to x is 4.6 minus 4 all over h. So our p is equal to 0.6. Our yp, according to the formula, is yn plus p, first backward difference of yn of 1 factorial plus p plus 1, second backward difference of yn over 2 factorial plus p plus 1, p minus, no, plus 2, second backward difference of, no, there's a problem here, we shouldn't include this one. Oh, we have that one, p plus 2, that backward difference of yn over 3 factorial plus p plus 1, p plus 2, p plus 3, fourth backward difference of yn all over 4 factorial. Our yp is the same as f4.6 is equal to, now our yn is 269 plus is 0.6 is our p times first backward difference of yn 182 1 factorial plus p plus 1 p plus 1 which is 1.6 times second backward difference of yn 112 over 2 factorial is 2 plus p with 0.6 p plus 1 p plus 2 2.6 times that backward difference of y naught 60 over 3 factorial which is 6 3 factorial is 6 plus p with 0.6 p plus 1 1.6 p plus 2 2.6 p plus 3 3.6 times fourth backward difference of yn which is 24 over 4 factorial. 4 factorial is 24. Now f 4.6 is equal to 269 plus the working I will not keep on working it out using the calculator. 109.2 plus 53.76 plus 24.96, I hope there's some nothing wrong, plus 8.9856, which all together, I think that one might be beyond my camera range. That's why I'm avoiding a lot of lighting. Plus 8.9856. Let me remove this one here. I think it could be beyond the camera range. I have very small, limited space for working, which finally will give us 465.9056. 465.9056. So that is it. That's how we work it out. But always read the question keenly. You can see we are getting the same answer when you are using this line and also when you are using this line. The only thing that matters is how you find your p. That example is a bit wrong, but because we have got the extent of using this line and this line. So that is it. Remember to share the video with your friends who are in different schools. And also leave your question, which video would you like me to make, which year of study, year 1, year 2, year 3. And also always remember to watch the videos online. That is very key to support this channel grow and make more content for you.